We are from Software Editors, and for today's video, we are going to explain about the implementation of DevOps in CRMS. So we are a team of four. My name is Hafiz Bin, and we have Muhammad Hafiz bin Kamal, Muhammad Hadi Firdaus bin Hashim, and then we have Muhammad Muzamil bin Fikri Muhammad. So the Clinic Rupiah Management System, also known as KRMS, are actually a web-based clinic management system that digitalizes the patient records, prescription, and medication inventory for the Clinic Rupiah. So it replaced the manual paper-based process. So this web are actually built from modern stack, adding with a Python with AI-powered prediction. So the system was developed using hybrid plan-driven and also agile Scrum methodology across 3 sprints. So as part for this assignment, we are going to explain the DevOps CI/CD pipeline was implemented using the GitLab, SonarQube Cloud, Jira Cloud, and also DigitalOcean. So let's go on to DigitalOcean. So here we have our project RMS already set up with DigitalOcean. So this is the live application. So let's first log in first. User account 01. So as you can see here, these are the link of the live web application. We already put it inside our slide. In our deployment is that we are using the DigitalOcean application platform, which automatically builds and deploys the application from the repository. So as you can see here, we have done created integrated droplet for the KRMS, and then we have 2 droplets, which is the KRMS front end and also the backend. So the front end served on port 8080 with DigitalOcean domain, and the backend is accessible via the KRMS via its backend routing rule on the same domain. And then so for the GitLab repository here, is that we have been formed from the main KRMS project, and then the repository contains 3 main folders, which is the front end, back end, and also the Python. Which is front end, back end, and also the Python. So each with their own dependency and configuration. So we have also configured a dual mode setup so that when each developer commits push to GitLab are mirrored to GitHub as well. So which is what DigitalOcean pulls from for the deployment. So we also set up for this. This is a gitlab.ci.yml. So the GitLab CI/CD pipeline here have 4 stages, which is build, lean, code quality, and also deploy. So the build stage is install all the dependency for both front end and also back end, verifying the project compiles successfully. The lean stage here to check code formatting and style consistency, catching the issue earlier before they reach production. So the code quality, which is the Sonar Cloud integration, to perform a static code analysis on the entire code base. And so the final, which is the deploy stage, calls the DigitalOcean API to trigger a new deployment whenever code is pushed to the main branch. So let's go on to the SonarQube. So this is SonarQube Cloud. So this is the KRMS. So first we have. So this is a preview dashboard of the project. For code quality, we integrated Sonar Cloud into the pipeline. Sonar Cloud is cloud-based version of SonarQube that analyzes the code base on every pipeline run. So the KRMS, the project scan 96 files across front end and back end. The security rating is E, meaning there are no critical security vulnerabilities. Code duplication is around no code duplication. And then so here we have integration with the Jira as well.
Assalamualaikum, my name is Muhammad Hafiz bin Kamal. Today I will be presenting the description of the project and the system and software architecture of the Clinic Rupiah Management System, or KRMS. First, let me introduce the project. KRMS is a web-based clinic management system developed to improve and automate the daily operations of Clinic Rupiah, which is located in Chukai, Terengganu. Before the development of KRMS, the clinic relied heavily on traditional paper-based processes, such as handwritten patient records, manual inventory logs, and physical document filing systems. These processes were time-consuming, difficult to manage, and prone to human errors. To address these issues, KRMS was developed as a centralized digital platform that streamlines clinic operations and improves efficiency. The system supports 2 main user roles, namely clinic assistants and doctors. KRMS focuses on 3 main functional areas. The first is patient medical record management. This module replaces traditional patient records with digital medical records stored in centralized database. Staff can quickly search for and retrieve patient information whenever needed. To simplify the transition from paper records to digital records, CAMS incorporates a AI-powered handwritten text recognition feature using the Gemini Gen AI API. This feature can scan handwritten patient cards and convert them into structured digital records, significantly reducing the need for manual data entry. The second area is medication inventory management. This module enables real-time monitoring of medication inventory, including stock levels, manufacturers, batch numbers, and expiration dates. Historical inventory data is analyzed using machine learning models developed with Python's scikit-learn library to forecast future medication demand. This helps clinic staff plan inventory more effectively and reduce the risk of medication shortages. The third area is medical document generation. This module automates the creation of common medical documents by automatically filing templates with patient and diagnosis information stored in the system. Users can preview documents within the application and export them as PDF files. Supported documents include medical certificates, referral letters, school leave forms, receipts, time slips, and medical checkup reports. Next, I will explain the system and software architecture of KRMS. The architecture design of KRMS follows the Model View Controller, or MVC, design pattern. This approach separates the system into three distinct layers, allowing the application to be more organized, scalable, and easy to maintain. The first layer is the view layer. This layer serves as a user interface of the system. It provides dashboards, patient management pages, inventory monitoring screens, and document generation interfaces that allow clinic staff to interact with the system efficiently. The second layer is the controller layer. This layer acts as the core processing component of the application. It handles business logic, request processing, authentication, and communication between the user interface and the database. It also manages integrations with external services such as the Gemini API for handwritten text recognition. The third layer is the model layer. This layer is responsible for storing and managing application data. It contains information such as patient records, medical histories, medication inventories, generated documents, user accounts, and system alerts. The interaction between these layers follows a simple flow. Users perform action through the view layer, such as searching for a patient or generating a document. These requests are processed by the controller layer, which applies the required business rules and retrieves or updates information in the model layer. The processed results are then returned to the user interface and displayed to the user. By adopting the MVC architecture, KRMS achieves better maintainability, improved scalability, and clear separation of responsibilities between system components, making it easier to support future enhancements and long-term system growth.
I will be discussing on how our team handled Agile Scrum and continuous delivery to keep the KRMS system stable and up to date. First, we adopt a hybrid methodology by combining the flexibility of Agile Scrum with a more structured, plan-driven approach. We ensure that our feature and system improvement are delivered incrementally. This means we can adapt quickly without disrupting the clinic daily operation. Second is full traceability. Between our planning and our code, we use Jira Cloud to manage our sprint, and it is seamlessly integrated with GitLab. Whenever a developer push a code update, they tag the commit with a specific Jira issue key, for example, Scrum 6. Because of this, every single code change is permanently linked to its original task and pipeline result. Once a sprint goal is met and the code pass our automated testing, we rely on automated deployment. Our pipeline automatically push the validated code directly to our live virtual production environment, eliminating manual deployment errors. Finally, this automated setup enable a crucial feedback loop. We are deploying KRMS using a phased rollout strategy, starting with a small, focused group of clinical staff because we can deploy updates so quickly. We can gather their real-world feedback and immediately feed those improvements back into our Jira backlog for the very next sprint. This interactive cycle is what keeps KRMS highly adaptable to the clinic actual needs.
Okay, next is about the automatic build and release. So the first of all, the automatic is the foundation of CI/CD. It automates the retrieval of source code, compilation into binary, execution of tests, and publishing to a centralized repository, where this is to ensure software updates are delivered with consistency and speed. Second one is the hybrid methodology, where it integrates the structured planning with agile-based iterative development to maintain a stable yet adaptable system for the clinic. The third one is the automated build process, which is triggered automatically when developers commit code to the GitHub repositories. It also compiles the React front-end and the Node.js Express.js backend while ensuring the MongoDB data layer is correctly integrated. The fourth one is the progressive release strategy, where it employs a canary deployment to release the system incrementally to a small subset of clinic staff, minimizing the operational risk. They also retains legacy paper-based processes as a fallback until the digital system is fully validated. This is built to ensure faster deployment cycles, significantly reduces the human error, and then this will enhance the clinic's overall digital readiness.
For the summary, the Clinic Rabia Management System (KRMS) is a web-based application built on the MVC architecture, React, Node.js, and MongoDB to digitize clinic workflow, enhanced with Gemini AI for text recognition and scikit-learn for inventory forecasting. To ensure reliable software delivery, development is managed through a hybrid agile methodology using Jira Cloud for sprint tracking. This is seamlessly integrated with a robust CI/CD pipeline orchestrated by GitLab and Vercel for automated testing and live deployment. Throughout this process, strict code quality is enforced via a containerized SonarQube environment, ensuring the system passes its quality gate with a A security rating and zero code duplication before incremental rollout to the clinic staff. That's all. Thank you.